This is our Unit 8 Day 7 video. So yesterday we talked about the three basic trig ratios. Today we're going to be talking about the inverse trig ratio. So this warm-up, hopefully you had a chance to try this on your own now. And what we're going to do is using what we did before the break with the special right triangles, we're going to label the missing angles. So remember there were two kinds of special right triangles. We talked about the 45-45-90 and the 30-60-90. There was a special pattern for each one. For the 45-45-90 it was 1, 1, square root 2, and for the 30-60-90 it was 1, 2, square root 3. So using what we learned with the special right triangles, we're going to label the missing angles in each one of these triangles. For number 1, look at this triangle, see that two sides are the same. That means it's a 45-45-90. Follows that pattern, 1, 1, square root 2. So both our missing angles are 45 degrees. Second one is the 30-60-90. See, it follows the pattern 1, 2, square root 3. So it's the 30-60-90. Trickier part about labeling this one is which of these angles is the 30, which one is the 60. Remember that the smallest side, 1, always goes across from the smallest angle, which is 30, and then the largest side, the largest angle, so 90 is opposite the 2, and the square root 3 is opposite the 60. So using these angles and special right triangles, we can actually find sine, cosine, tangent for all three of these angles using what we did yesterday, SOHCAHTOA. So for this first row, sine 45, I'll look at a 45-degree angle in this first triangle. So sine is opposite over hypotenuse, so opposite side would be 1. Hypotenuse would be square root 2. So sine 45 would be 1 over square root 2, opposite over hypotenuse. Same thing for cosine. This one here is the adjacent side. So adjacent over hypotenuse would be cosine 1 over square root 2 also. And then tangent would be opposite over adjacent, so that would be 1 over 1, or just 1. For this next group, 30-degree angles, we're going to look at the 30-degree angle on the 30-60-90 triangle. So here the 1 is opposite, square root 3 is adjacent, and the 2 is hypotenuse. So the sine for 30-degree angle is 1 over 2, opposite over hypotenuse, so cosine adjacent over hypotenuse, square root 3 over 2, and then tangent for 30 is opposite 1 over adjacent square root 3, so write that as 1 over square root 3. Do the same thing with the 60, except we have to relabel the sides. With the 60, this side is now the adjacent, square root 3 is now the opposite, 2 is still the hypotenuse. So we do sine, opposite over hypotenuse is now square root 3 over 2, cosine 1 over 2, adjacent over hypotenuse, and tangent is square root 3 over 1, which is just square root 3. So these trig ratios for sine 45, 30, and 60, these show up a lot on the ACT and SAT. The reason is because you can do all of these without a calculator. So that's why these special angles are important, these 45, 30, and 60-degree angles. So what we're going to be talking about today is inverse trig ratios. And what we use inverse trig ratios for is we use those to find angles. We use to find angles when we know either the sine, the cosine, or the tangent ratio of the angle, but we don't know the angle itself. There's three inverse trig functions we'll talk about. First one is inverse sine. So the way we write these inverse functions is we use a -1 superscript. So sine inverse is how we write that. The -1 represents the inverse. So inverse sine is also called arc sine. We use this to find an angle if we know the ratio of the opposite side to the hypotenuse. So we know the sine ratio. So this first example says sine inverse 1 over square root 2. What this means in words is an angle with a sine ratio of 1 over square root 2. So another way of saying that with a picture is saying if this angle here is our angle x, the opposite side would be 1 and the hypotenuse would be square root 2, since sine is opposite over hypotenuse. So this angle here on the picture represents what this is saying with the symbols. Inverse sine 1 over square root 2 means an angle that has a sine ratio of 1 over square root 2. The ratio of the opposite to hypotenuse is 1 over square root 2. And then using what we know about special right triangles, we know that this would have to be 45 degrees. It fits the pattern for a 45, 45, 90 triangle. Same idea for the second example. This is inverse sine 1/2. What that means in words is an angle with a sine ratio, which means opposite over hypotenuse, equal to 1 over 2. So if we were to mark this angle on the triangle to represent what that's saying, this would be our angle x. The opposite side would be 1, and the hypotenuse would be 2. Right, and that gives us an angle that has a sine ratio of 1 over 2. And then again, using what we know about the special right triangles, we know this has to be 30 degrees. This fits the pattern for the 30, 60, 90. So just like inverse sine, we also have an inverse for the cosine function, and that's called arc cosine. Inverse cosine or arc cosine, using both the same. And we use this again to find an angle. We always use inverse trig to find angles when we know the ratio of the adjacent side to the hypotenuse. So we know the cosine ratio this time. This will be pretty much the same as what we did before. Cosine inverse square root 3 over 2 means if I mark off an angle, right, remember that cosine is adjacent over hypotenuse. I'm going to mark off this angle x to have an adjacent side of square root 3 and a hypotenuse of 2. Then it would have a cosine of square root 3 over 2. And then using what we know about special right triangles, we can tell this would have to be a 30-degree angle. This one here would be a 60, and this missing side would be 1. This fits the pattern for the 30, 60, 90. Same idea on the second example. Right, cosine inverse 1 over square root 2 means if I mark off an angle, I'm going to set the adjacent side equal to 1 and the hypotenuse equals square root 2. That way I have a cosine of 1 over square root 2. Then again, we look at what we did with special right triangles. This fits the pattern for a 45, 45, 90 triangle. We have the 1, we have the square root 2. We know the other side has to be 1 also, so these angles are both 45. So this first one was 30 degrees, and the second one was 45. So the last one we have again follows the same way. It's inverse tangent, which is also called arctangent. And again, we use it to find an angle if we know the tangent ratio. And tangent ratio is the opposite over the adjacent. So I know when I'm using inverse tan, I'm always going to be marking off my angle, looking at the opposite, looking at the adjacent. So on the first one, it tells me I have a tangent ratio of 1 over 1. Angle with a tangent ratio of 1 over 1. So look at that, we see two sides are the same. Right, this fits the pattern for our 45, 45, 90. So we have 1, 1. We know this side will be square root 2. We don't need to find that, but just to fill out the triangle so you know, this has to be a 45-degree angle. So inverse tan 1 over 1, 45 degrees. Same idea on the second one. We have tan inverse square root 3 over 2. And if I mark off an angle here, I know the opposite side would be square root 3, and the adjacent side would be 1. Alright, then think about the special right triangles. This matches the pattern for 30, 60, 90. So here the angle is opposite the square root 3, which means this is the 60-degree angle, not the 30. So the important takeaway for these notes is remember this semester and when you take Math 2 next semester, that inverse trig is used to find angles. If you don't find any other resources to help you out with this or look for different videos online, just search for inverse trig functions.